EKG of the week. Let's run through another real-life EKG. Take a second, as usual, take a gander at this EKG and come up with your interpretation. And when you have it, then start the video again and we'll run through it. Let's walk through this guy. So this is a pre-hospital EKG. There's no rhythm strip, but we will be able to figure it out. It's still a 10-second strip. We can still calculate the rate off it without having to look at the computer. Let's see how close we get. So if we count the number of QRS complexes, we get 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, 6-second strip. 9 times 6 is, 54? And maybe cheat a little bit. Somewhere between 50 and 60 certainly is what it looks like. Computer says 52, but 54, somewhere around there, 55. A little bit bradycardic nonetheless. Rate, rhythm. Let's see, are there P waves? I see P waves. I note them in lead V2 here, and I can kind of see them otherwise. It looks like there's a P wave before each QRS and a QRS that follows each P wave as best I can see, and they all look more or less identical and normal-ish. So I'm going to say this is sinus rhythm. So we've got a sinus bradycardia so far. Rate, rhythm, axis. Looking at the axis, we look at lead 1, and we are mostly upright in lead lead 1. We are mostly upright in lead 2, and we are mostly upright in lead AVF. So if you pull out a chart for it, I'll tell you that it's normal because we've done this enough, but when you look at it, here is lead 1 here, positive-wise. That's all going to be on this side. Lead 2 positive is over here. Lead 3 positive is over here. And the only place where those all intersect is somewhere in there. So this is going to be a normal axis. Rate, rhythm, axis. How about intervals? Let's take a look at the intervals, and we may have to look kind of closely on this one. So we got to find our P waves first. Let's look at the PR interval. There's a good looking P wave, as is that one. So, again, as always, the start of the P wave to the start of the QRS, if it is normal, should be under one big box or 5 little boxes in length. And it looks like that is kind of right on the edge of 5 little boxes. Some of the other, if we look at some of the other T waves here, like the one kind of immediately before it that's just a little bit clearer, that one to me looks like it's a bit like that distance is a little more than one big box or 5 little boxes. I'm going to call this a borderline first degree AV block, or borderline PR elongation at least. And again, depending on which one you look at, some of the leads look more convincing than others. A little hard to say, but we'll say that it is either slightly long or on the edge of long. So PR interval there. How about QRS complex? QRS width should be under 3 little boxes. And if we look at that one, we can count 1, 2, and the QRS is finished. So that looks like a normal QRS, a normal QRS width. And then looking at the QT interval, again, just judging, does it kind of fall, does it finish up, does the T wave finish up halfway between beats? And it looks like it is probably finished by the time you get halfway in between these 2 beats. So this is probably a normal-ish QT interval. So we'll just say that we have borderline prolonged PR at this point. And if it is borderline prolonged PR, it looks like the PR interval is pretty constant between them. It doesn't look like there's a ton of variation, at least in terms of, longer drop or long drop beat or something like that, or dissociation. So I'm going to say I think this is maybe borderline first degree AV block. All right, rate, rhythm, axis, intervals, and blocks. How about ischemia and infarcts? You've probably been looking at this one already, but let's just make sense of it. Again, I start in a vascular territory, so looking at the lateral leads because they're upper left corner, and that's where my eyes go to. It looks like we have some pretty significant downsloping ST depression in lead 1 here, and similar ST depression with a flip T wave in lead AVL. So that's concerning for ischemia, certainly. When we look through the inferior leads, we start with lead 2, and Maybe there's a hint of depression there, or a hint of elevation there, not too awful much. But when we get to lead 3, we see it a bit more prominently, depending on, again, on which TP segment you compare to, which baseline you compare to. That looks like more than a millimeter. It looks close to it. When we get into lead AVF, we see kind of the same thing. That looks like there's a millimeter of ST elevation there on both sides. So I'm concerned at this point that we have at least a millimeter of ST elevation in the inferior leads. It follows a vascular territory. It's in 2 leads. I'm concerned this is an inferior STEMI. When we look through the precordials, because you got to look through everything, we see again a little bit of ST depression with a T-wave inversion in lead V1. V2, same thing, bit of ST depression, T-wave inversion, maybe concerning for ischemia, or if not ischemia, those could be reciprocal changes, because whatever happens on one side of the heart, the opposite, the electricity going the opposite direction through the opposite side of the heart, will do the opposite thing. So if you have ST elevation in the inferior leads, the anterior leads and the lateral leads maybe will show reciprocal depression, because one goes up, the other goes down. So it could be ischemia out in the anterior leads, or more likely reciprocal changes. Not a lot of changes in lead V3 here. V4, similar. V5, no real big changes. V6, no obvious ST elevation or depression. So we've got ST depression in the inferior leads, 3 in AVF especially, maybe a little bit in 2, and some wacky changes in lead 1 and AVL, which are the opposite side of the heart. So you'll get, instead of ST elevation as a sign of injury, you get ST depression, which is what I think we're seeing here in these leads in AVL. So looks like reciprocal changes. This makes sense for an inferior STEMI, and that's what I'm going to call it. Inferior STEMI is what I'd be concerned about in terms of that infarction. How about any other patterns or anything? Peak T waves, hyperacute, Brugada pattern, anything like that? No, I don't see any of those obvious things. And so that leads us, we have a bradycardic rhythm. It looks like a sinus bradycardia with maybe a borderline prolonged or maybe borderline prolonged PR interval, maybe borderline first degree AV block, and ischemic signs or ST elevation concerning for inferior STEMI with reciprocal changes in the lateral leads. So my impression is going to be this is an inferior STEMI. That's the interpretation on this one. If you have any questions, let us know. Put them in the comments. And otherwise, we will see you later. Stay safe out there.